Hi guys, I hope you're all doing well. I miss you guys. You guys have no idea how much I miss being in the classroom with you all every day. Um, so today we're going to be looking at some more Punnet square practice. So you're going to be here in the Tuesday Punnet square follow along. Obviously it won't say draft when you're doing it. So you're going to click on this sheet right here and it's going to take you to this worksheet, and I'm going to be going over two of the problems with you, and then you're going to be completing the other two by yourself. So this is a new kind of form that we're trying out this week. So this is a self-correcting form. So each of these bolded squares, you're going to be typing an answer into. And when your answer is correct, it's going to be turning green. If it stays white, it means you need to keep trying until you get that green, because that green means you're correct. So you'll see what that looks like as we go through these. So first, we're looking at mice today. So what we need to know about the mice is in the laboratory mice, gray coat color is dominant over albino coat color. So we know that dominant traits are shown with capital letters. So gray is big G, and then our recessive albino trait is going to be little g. So that's what you need to keep in mind as we go through these. So the first scenario, we're going to be crossing a female with a big G, little g genotype with a male little g genotype. So in this scenario, in these first two scenarios, I already have the genotypes put in the Punnett square for you. So as we know, as we go into each square, you're going to look at what's above it and what's to the side of it, and you're going to combine those to get your genotype. So this first one will be big G, little g. So I have it typed, and now in order to see if my answer is correct, I need to click outside of the square. So I'm going to click outside of the square, and you see it turns green, so that means you're correct. If you had put in the wrong answer, say you put in little g, that square would stay white. So remember, you have to click out of it to see if it's going to turn green or not each time. So this next one over here on top, we have a little g, and over here we also have a little g. So we're going to have little g, little g. Over here on top, we have a big G. On the side, we have a little g. So we're going to have big G, little g. And then over here again on the top, we have little g. On the side, we have little g. So we're going to have little g, little g. So you see all of your Punnett squares by the time you're done should look like this, 4 green squares. This is going to be how I'm grading it. I'm going to be looking for the green. So there's no reason everybody can't get 100% on this one. So once you get your Punnett square filled out, you're going to go over here and you're going to fill out these questions. The big thing with this is the ones that are asking for percentages or probabilities, do not put a percent sign, just put the number. So if you want to say 50%, just say 50. If you want to say 75%, just say 75. And I've put that on each of the questions so you don't forget. So the first question in the scenario is, what color is the female mouse? So if we go back to our scenario, our female mouse has a big G, little g genotype, which we know is heterozygous genotype. So remember, our dominant traits, whenever we have one of them, they're going to beat out that recessive trait. They're the strong trait. They're going to mask the recessive trait. So our heterozygous female is going to have the big G expressed, which we know means she has a gray coat color. So our female is going to be gray. And then you click out, and we see that's green. That means it's correct. So let's look at our male mouse. So our male mouse has little g, little g. So we know that's homozygous recessive, because remember, homozygous means 2 of the same letters, and then recessive means lowercase. So 2 lowercase is homozygous recessive. Since we have 2 recessive alleles, that recessive trait actually gets expressed because there's no dominant trait to mask it. So our male is going to have that recessive trait. He's going to be albino or white. So our next question is, what is the probability of getting gray offspring? So with gray offspring, remember, gray's our dominant trait. So you don't have to have 2 big G's to have gray offspring. You can have 2 different genotypes. You can either have 2 big G's or you can have one big G and one little g, like we see here. So both of these two would result in a gray offspring. So remember, each one of these squares represents 25%. So 2 of the squares are filled in with a genotype that would result in gray offspring. So that means we have a 50% chance of getting gray offspring. So remember, no percent signs. So you just type the 50 and click out and you have your green. Next question is, what is the probability of getting albino offspring? So remember, our albino offspring, that's the recessive trait. So in order to have an albino mouse, you have to have a homozygous recessive genotype. And here we have 2 squares that have that genotype. So remember, each square, 25%, so 25%, 50%. So in this scenario, we have a 50-50 chance of gray offspring and albino offspring. The next question, what is the probability of getting heterozygous offspring? So remember, heterozygous means 2 different. So that's going to be a capital and a little letter. So in this scenario, we have 2 squares that have a heterozygous genotype. So again, it's going to be 50% chance. And then what is the probability of getting homozygous offspring? So remember, homozygous is when we have 2 of the same. So you have 2 options. It could be either be big G, or little g. In this scenario, we don't have any big G, but we do have 2 little g's. So 2 squares, that means a 50% chance of getting homozygous offspring. So that's the first scenario. Next, we're going to skip down and we're going to be going over scenario 3. So these last 2 scenarios are a little bit harder because you guys need to figure out what the genotypes of the parents are, given the hints, and you need to fill them in. So this scenario asks us to cross a homozygous dominant female, which we're going to be putting on the top of the square, with an albino male, which we're going to be putting on the side of the square. So homozygous dominant. Remember, homozygous means 2 of the same. Dominant means capital letters. So we're going to have big G, which we'll put in up here. So big G, big G. Next, we have our albino male. So if we scroll back up to the top, remember, albino is the recessive trait. In order for the recessive trait to be expressed, you have to have both recessive alleles. So we know that our albino male is going to have 2 little g's, or he's going to be homozygous recessive. So on the side, we'll have little g, little g. So we see that those are correct. So now we're going to fill out the rest of our square. So big G on top, little g on the side, so we have big G, little g. Again here, big G and little g. And over here, we have another big G, little g, and again, another big G, little g. So you can see if we have one homozygous dominant parent and one homozygous recessive parent, you're always going to get heterozygous offspring. That's because if we look here, mom only has big G's to give, so you know she's going to give a big G allele. Dad only has little g's to give, so that you know dad's going to be giving a little g. So the only option for the outcome is big G, little g, or a heterozygous genotype. So let's go over here and look at our questions. So the first one is, what is the color of our female mouse? So remember, our female mouse is homozygous dominant. And remember, our dominant feature is gray fur, so she's going to be gray. And then our male mouse, it tells you, he's albino, so he's white. And then what is the probability of getting gray offspring? So remember, gray is the dominant trait, so you have 2 options here. You can either have homozygous dominant, which is big G, Or you can also have the heterozygous genotype, which is big G, little g. That gray dominant trait masks that white recessive trait. That gray trait is stronger. It's going to cover it up. Whenever you even have one big letter, that's going to cover up that small letter. So from the outside, you won't even know it's there. So our probability of getting gray offspring is going to be 100% because all of our offspring, they have a 100% chance of being heterozygous, which is going to result in gray fur color. So you have 100 right here. What is the probability of getting albino offspring? So remember, albino is recessive, so we need to have 2 recessive alleles for it to be expressed, or little g, little g. We don't have that as an option at all over here, so there's a 0% chance of having an albino offspring, even though that father is albino. What is the probability of getting heterozygous offspring? Remember, heterozygous means 2 different, so you'll have a big and you'll have a little. All of our squares are heterozygous over here, so 100% again. And then what is the probability of getting homozygous offspring? Remember, homozygous means 2 of the same, either 2 bigs or 2 littles. As you can see over here, that's not an option at all. So we have a 0% chance of homozygous offspring. So one thing that I want you guys to remember, because I know this has been a common misconception going out throughout this unit, just because a trait is dominant does not mean it's more common. Remember, a human having 6 fingers is dominant over having 5 fingers. Do we all have 6 fingers? No. Just because a trait is dominant does not mean it's common. There's not a lot of that dominant allele floating around. There's more recessive alleles floating around in the gene pool. So we have more humans with 5 fingers than 6 fingers. So when I say dominant, I don't mean more common. I just mean if it's present, it's going to mask that recessive allele. So you only need one of them to be seen on the outside. So now I'm going to have you guys do scenario 2 and scenario 4 by yourself and turn it into me. Remember, I want to see all green on here. There's no reason for everybody not to get 100% on this because you know immediately if your answer is correct or not. If you need any help, please, please, please reach out to me. I'm here for you guys. I want to help you. I miss you guys. I love hearing from you. You can email me, you can text me, you can call me, you can chat me, whatever works best for you. If you need help, please ask. I hope you guys have a good day and a good week and a good long weekend. Bye, guys.